Greetings everyone. Let's have a quick review of the compass rule and the transit rule in adjusting a traverse. So as you can see here, we have our figure with the lines having their corresponding bearings and lengths. Also, we have here the coordinates of corner 1 in green right here in the upper right. So before we can proceed with the compass rule, we need the perimeter. So we need to add up all of these sides right here. And if you add that up, our perimeter will be 3739.48. Okay, so um, let's just write it down below. Okay, so I've already tabulated the values, so let's just study how we got these values. So let's say we have a perimeter of 3739.48. Okay, so we have here in unadjusted latitude and departure. So let's just recall quickly how to get the latitude and departure. Let's say we have here corner A and we have corner B here. We have a line right here, line AB, and then we have the length of 690.88. And then we also have an angle. We also have an angle of, this is 79 degrees, 49 minutes, 00 seconds. So this is a southwest, right? So in order to calculate for the latitude and departure, so we'll just use Sokotawa. So we have here, in order to get for latitude, you get cosine theta is equal to latitude over hypotenuse, which is 690.88. So latitude, therefore, is equal to cosine 79 degrees, 49 minutes, multiplied by 690.88. Okay. And then for the departure of line AB, so we will use sine 79 degrees, 49 minutes, multiplied by 690.88. So that's how you get your latitude and departures right here. And I'm sure you already know how to do that. So um, you just have to do all of the lines right there, and then you will get these values. Okay, so let's proceed with uh, the compass rule. Okay, let's erase these first. Erase this. Okay. So the first thing that we need to do is we need to identify the error in the unadjusted latitude and departure. So if this is no error, then the unadjusted latitude and departure should sum up to 0, right? But if it does have a discrepancy, then we'll find out. Summation of latitude here is negative 0.68. The summation of departure here, let's write that properly. Summation of departure is equal to 1.05, positive 1.05. So we have an error here of negative 0.68 and 1.05 in the departure. Okay, so how are we going to adjust it using the compass rule? So for the compass rule, the formula for that is, let's say we want to get the correction. Let's focus on this line AB. So we want to get these values right here, the corrections. So correction AB, let's say this is the latitude, is equal to negative of the error, as you can see right here, total negative 0.68, and you divide that by the perimeter, which is 3739.48, and then so you divided the summation of the latitude or the error divided by the perimeter, and then you multiply it by the length. So you can see here the length 690.88. Okay, so if you do that, you will get a value of 0.13. Now let's say we want to get the for departure. So we have here negative um, 1.05, as you can see right here, and then divided by 3739.48, multiplied again by that 690.88. So if you calculate that, you will get negative 0.19. Okay, so if you do that all over again here, so you will get all of these values. Now, since we've already calculated the corrections, you can check also, you can double check your corrections. They should sum up to, they should sum up to our latitude should sum up to 0.68 for it to cancel out all of the error, and then the departure should sum up to a 1.05. Okay, so let us adjust the coordinates of the figure, the corners. So, but before that, you can also add up. So, if you add this unadjusted and this corrected right here, you will get negative 122.02. And then for the departure, this one and this one, you will get this one. Okay, so for getting the coordinates of the corners, you basically have to just add the corrected departures, latitude and departures, and then uh, just do it over and over until you return to corner A. And as you can see here, we have 857, same as our initial, same as here. Okay, so that's it for the compass rule. So how about if we want to do the transit rule? Okay, so we have the same table right here in the first few columns. So they differ in the correction. So before doing the compass, the transit rule, you must first add up the latitude, unadjusted latitude and departure. So we must take the magnitudes only. So we will disregard the signs. So let's write it here. Summation of the absolute value of latitude will be 1862. And then, so let's transfer it a little bit lower. And then we have here the oh, summation of the departure, the absolute value still, it will be 2543. So, of course, the summation of latitude will be the same. So you will have here total of that negative 0.68, and then summation of departure will be 1.05. Okay, so let's say we want to calculate again, focus on line AB. So the correction, in using the transit rule, if you want to calculate the correction for line AB, correction AB, latitude. So what you need to do is take the negative of the same thing, the error, 0.68, and then negative, this is negative, and then you divide it by this right here, the summation of the absolute value of the latitude. So 1862. And then you multiply it not by the length of the line, but the latitude, the magnitude of the latitude. So you don't need the sign here. So 122.15. So if you calculate that, you will get a value of 0.04. So here it is. Now, if you want to calculate for the departure, then the same method, negative 1.05. Now divide here this one 2543, and then multiply it by the departure. So 679.99. So if you multiply that, if you perform that operation, you will get negative 0.28. Okay, so in correcting the coordinates, it's the same thing. You just correct the unadjusted with the corrections, and then you add those corrected latitude and departures to the corner A until you reach corner A again. So as you can see right here, just add. Okay, so basically that's it for the compass rule and the transit rule. So I hope you refreshed your memory about it. And yeah, thank you for watching, and we'll see you in the next video.